Good afternoon, everybody. How are you all? Today we are going to talk about analysis of variance test. So I'll share my computer screen with you. A researcher wants to determine whether there is any difference in the weight gains of athletes following one of the three special diets. Athletes are randomly assigned to three groups and placed on the diet for 6 weeks. The weight gains in pounds are shown below. At alpha equal to 0.05, can the researcher conclude that there is a difference in the diets? So the first thing we will do is clear the memories, use TI-84. Use TI-84. The first thing we will do is press the second button on the top left, then the plus button on top of the enter button on the bottom right corner, then select number 4. When we do that, we will get clear all list in our calculator screen, and we will press enter after that, and we will get done. Done what? Cleared the memories. Cleared the memories. Okay. This is very important to clear the memories of the calculator to do a new problem. Okay. So the first thing we will do is press this. Next thing we will do is start button. Then select number 1, which is edit, and enter diet A data in L1. Okay. So when we are done with entering the 4 data points in L1, we will press the right cursor key. Okay, this is the right cursor key. Right cursor key. To move the cursor to the first line in L2. In L2, where we will enter diet B data. B data. Okay. Okay. The next step, after entering the data, diet B data in L2, right cursor key. Cursor key and move and enter diet C data in L3. L3. Okay. So, and we have entered the data in L1, L2, and L3. Okay. Now I will show you how to do this calculation 2 ways. Okay. First, I will show you the long process of the real calculations. Then I'll show you the easy process. Okay. If you have TI-84, that is. So let me move this further up. Okay. Okay. So once you enter the data, then you do stat calc and number 1, which is one var stats. One var stats means one variable statistics. Okay. So stat button, then calc button, then number 1, which is one var stat. First line list is L1. If it is not L1, you can do it L1 by pressing the second button and then number 1 button. Second and 1 will make it L1. Like mine is L2 now. I'll make it L1 by second and 1. Next line should be empty. There should be nothing to the right of the colon in the second line. So this should be empty, nothing there. And then we go to calculate and hit enter. Okay, calculate, put the cursor on calculate and hit enter. So we get X bar. Sample mean for A. Remember, this is all for A. Okay, X bar is 5.5. Sx is equal to 1.29. And then we also need this information. Sum of all X. Sigma stands for sigma is sum. Sum of all X is 22. Now we will repeat this. So this is for, we might call it A, just to know it is for diet A. We'll repeat this process for diet B and diet C in L2 and L3. And I will write the information down here. So repeat stat calc number 1 where stats. Okay, list is L2. How do you make it L2? Second button and 2. And then frequency list is empty. And then calculate. Okay. So stat calc 1 where stats list is L2, second and 2. And then we go down to calculate and hit enter. And we get XB bar is equal to 10.167. SXB, this is SXA by the way. And SXB standard deviation, sample standard deviation for B is 2.858. And sum of X is equal to 61. Okay. Now let's move it up a little bit more and repeat this process for L3. Repeat it for L3. For L3. Okay. So stat calc 1, second and 3. And frequency list is empty. Calculate. And XC bar is equal to 4.5. SXC, sample standard deviation for sample C, is 2.646, you might say. And sum of X is 18. Okay. Now we need to calculate X double bar, which is the grand average of all data points. And that is equal to sigma XA plus sigma XB. So this is sigma XA, this is sigma XB, and this is sigma XC. XB plus sigma XC by NA, number of samples in sample A plus NB plus NC. And that is equal to 22 plus 61 plus 18 divided by 4 plus 6 plus 4. So X double bar, grand average of all data points, is 22 plus 61 plus 18 is 101 divided by 14. 4 plus 6 is 10 plus 4 is 14. So this is 14 number of samples for all the samples. So 101 divided by 14 is your grand average, which is 7.214. Okay. So we need all this information to do the calculations. Okay. So what calculations are we going to do? That is the question. Okay. Let's move this a little bit up. So we are going to compare the means. So the null hypothesis is mu A, that is the population mean of diet A is equal to population mean of diet B is equal to population mean of diet C. That's your null. So this is your null. And your alternate is H sub A is at least one of the mu's is different. One of the mu's is different. Mu's is different. Now, in order to compare the means, we will compare basically the variances. So the first thing we will do, compare the variances or compare the variations of each group of sample means. Sample means from the grand mean. Grand mean. This is one way, and this one, this compare the variation. This is called SSTR or sum square treatment. Sum square treatment. Later on, you will see in calculator, treatment is diet A is a treatment, diet B is a treatment, diet C is a treatment. In your calculator TI-84, this is called SS factor, sum square of factor. A is a factor, B is a factor, C is a factor. So that's one way we'll compare the variation or compute. Okay. So this is let me make sure that so first we compute. So let's erase this. So this is not compare, this is erase. So we want to compute the variation of each group sample mean from the grand mean. This is called sum square TR or sum square treatment, which is same as sum square factor. Each of the diet is a treatment or a factor. Let me then move up. The other variation we are going to calculate is to compute the variation within each sample. Within each sample. And this is called sum square error. Sum square error. The whole idea in ANOVA is that if the means are equal, then the sum square treatment or the variations of the sample means from the grand mean should be equal to the sum square error or variation within each within each sample. If the means are equal, then sum square treatment is equal to is almost equal to sum square error. Okay. Now, if the variations are quite apart, then of course the means are not equal. Okay. Now, let me show you the calculation for sum square treatment. Okay. So basically, how do you calculate sum square? Remember, it is a variation of each sample mean from the grand mean. Okay. So for example, for A, the mean, sample mean is 5.5. And how far is it from the grand mean, which is 7.214? And since it is sum square, we squared this variation and then we multiply it by the sample size in A. So this is from A. Okay. So this is XA bar and this is X double bar, grand mean. Okay. Plus sample size in B was 6 and its mean was 10.167 minus 7.214 and you square it. So this is coming from B. This is XB bar and this is the grand mean. Okay. Plus there are 4 samples. Sample size is 4 for C and its mean was 4.5. How far is it from the grand mean? 7.214 and you square it. 4 comes from the sample size. So this is NA, this is NB. So all the squares are multiplied by the sample size. This is NC. And this is coming from C. So this is XC bar and this is the grand average. Okay. So the sum square treatment is equal to, if you do the calculations correctly, is 93.535. How will you do it in your calculator? Well, you take 4, then left parenthesis, 5.5 minus 7.214, right parenthesis, press the X square button, plus 6, left parenthesis, 10.167 minus 7.214, square it, plus 4, left parenthesis, 4.5 minus 7.214, and you square it. And you add them and you get 93 points. Now, we also calculate a mean square. So this is the total sum square of the variations, and we want to find a mean of this. So MSTR is something we find out. MSTR is mean square treatment. And this is equal to sum square treatment divided by K minus 1. What is K? Is number of groups or number of treatments. In our case, we are comparing diets A, B, and C, so K is 3. So MSTR for us is equal to 93.535 divided by 2. And that is equal to, if I move this a little bit up, okay, MSTR works out to 46.767. 46.767. Okay. Okay. Now we are done with part 1. So this was calculations all for calculation for number 1. Okay. Sorry, this should be over here. So if I erase this and bring it back over here. So now we are going to calculate, move it up a little bit. we will do the calculation for sum square error. This is how much each sample, how much is the variation in each sample, square it, that is the variance, and multiply it by sample size minus 1. Okay. So first one, sample size is 4. 4 minus 1. The sample standard deviation is 1.291. 1.291, and you are squaring it because you're doing the variance calculation. Next one, 6 sample size minus 1 multiplied by the variance, which is the square of the standard deviation, which is 2.858 square, plus the next one, 4 sample size, is subtract 1 multiplied by variance, which is standard deviation square, which is 2.446. 2.646 rather. 2.646 square. Okay, and this works out to 66.8448. Okay, now just like before, we also calculate MSC. So this is called sum square error. Square error, this one, which is basically sum of the variances within each sample, and this is called, this one is called sum square treatment, like I said before. Sum square treatment, that is variation of each sample mean from the grand mean. Now mean square error is equal to sum square error divided by total sample size minus k. Okay. So sum square error is 66.8448, and we are dividing by n. We have 14. N is the total number of sample size, minus k is 3. N is total number of sample size. Total number of sample size, which is 14 from A, B, and C. And K is, of course, number of treatments. K is 3. So this MSC then becomes 6 MSC. Okay, let me write it clearly. So let me erase this. So, move this a little bit up. So I'm changing the color of the ink also. F is equal to, no, not F, I have to calculate. So let me erase this. I have to calculate the MSC. Use this one. So MSC is equal to 66.8448 divided by 14 minus 3 is 11, and that is equal to 6.076. Okay. So we had MSTR and MSE. Okay. This is your MSTR. Okay. So now we will calculate the test statistic. Test statistic is F, which is a ratio of two variances basically, S1 square by S2 square. Here it is the variance of each sample mean from the grand mean, MSTR, divided by variation within each sample, MSE. So this is equal to 46.767 divided by 6.076, and that is equal to 7.696 is equal to, it is that it is equal to 7.696. Okay. Now we also should remember, so I'll create some space, that degrees of freedom in the numerator of freedom of MSTR, remember, is K minus 1, which is 3 minus 1 equal to 2, and degrees of freedom of MSE is equal to N minus K is equal to, we know it's 14 minus 3 is 11. This is called degrees of freedom in the numerator, freedom in the numerator, This one, 2, and this is the degrees of freedom in the denominator. Freedom in the denominator. Okay. Now I will create some space and show you a diagram of the F distribution. So F distribution looks like this. Probability on the vertical axis, probability density on the vertical axis, and on the horizontal axis F. F distribution always starts from 0. F cannot be negative since it's the ratio of two variances, which is square quantity. And it is positively skewed. It extends to infinity on the right, which in your calculator you will represent by 1 exponent 99. That means 1 followed by 99 zeros. Now, remember our null hypothesis is mu A equal to mu B equal to mu C, and our alternate is at least one of the mu's is different. One of the mu's is different. Okay. We calculated a F statistic. Okay. And this test, F test, is always a right tail test. Is always a right tail test. Right tail test. Okay. So our test statistic that we calculated is, if I move this a little bit, is 7.696. Okay. So this is somewhere over here, maybe. F is 7.696. So we will calculate a p-value. P-value is the area under the F curve to the right of the calculated test statistic, to the right of the test statistic. Right of test statistic. So that's your p-value. So that means this area basically is p-value. So if you have TI-84, you can easily find this out. I'll show you in a minute. So in your TI-84, so this is for TI-84. Press the second key, then the worst key, which is in the third row, and scroll down with the down arrow key to FCDF. C stands for cumulative distribution. Okay. So second words in the third row, scroll down to FCDF, not PDF. Okay. So you will type lower as 7.696 because you are starting from 7.96. Your upper is 1, then E. How do you get E? This is second button and comma. Where is comma button? On top of 7 button. Second comma will give you the E and then you type 99. Now, then it asks for degrees of freedom in the numerator and we already know it is 2. And degrees of freedom in the denominator is 11. Okay. And then you go to paste, bring the cursor on paste and hit enter and enter twice. Enter and enter. Okay. 7.696. And paste enter and enter. And p-value is 0.008. Compare it with the alpha. Remember, alpha is level of significance. Is 0.05 given. Okay. So P is less than alpha. Decision reject H0. Reject H0 because P is less than alpha. Conclusion at alpha equal to 0.05. There is enough evidence to support HA, which states that HA, at least one of the mu's is different. One of the mu's is different. Mu's is different. Okay, so this is the long way of doing it. Now, let me show you the short way of doing it. Much shorter way of doing it. Much shorter way with TI-84. We have already entered data in L1, L2, and L3. Okay. So the next thing we do is press the second key, then verse key in the third row, then scroll down with the down or arrow key to ANOVA. Okay, so second key on the top left, then verse in the third row, then scroll down to ANOVA. No, I'm sorry. I have to erase that. So this is not the way to do it. So let's erase that. We have already entered data in L1, L2, and L3. Okay. So let's go back to this. Okay. So we have already entered data in L1 and L2. So press the stat button. Press the stat button. Then highlight test on the top row. Highlight means bring the cursor on test. Okay. And scroll down. Now you scroll down to ANOVA. Okay. So scroll down to ANOVA. And hit enter. So line your cursor with ANOVA, okay, and hit enter. So on your calculator screen, you will see ANOVA after you've selected ANOVA with the left parenthesis. Inside, you will first put L1, second one, then comma, L2, second 2, comma, L3, which is second 3, and the right parenthesis, and hit enter. So inside the parenthesis, second 1, comma, second 2, comma is on top of 7, second 2, then again comma, second 3, and close the right parenthesis and hit enter. Yes, and you get the same result. You get test statistic F is your test statistic. Remember, F is the ratio of two variances. Okay, one is the variation of each sample mean from the grand average, and the second one is variation within each group of sample. So it's a ratio of two variances. Test statistic is 7.696, and your p-value is also 0.008. Again, alpha is given as 0.05 given. So p is less than alpha. Decision is reject 80. Same as before. Okay. So I'll stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. And if you like this video, please share it with your friends. You and your friends, please subscribe to my channel by hitting the subscribe button at the bottom right corner. I will see you next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day.